National Electrical Manufacturers Association sets standards for electrical equipment, including LED luminaires. ANSEC 136.41 is a key NEMA standard for smart lighting, defining receptacles and controllers for LED fixture connections. NEMA standards ensure device compatibility, simplifying the integration of compliant products into systems for manufacturers and end users. In a NEMA design, the AC main supply powers the controller first, providing connectivity, dimming control, surge protection, AC-DC conversion, energy metering, and load switching capabilities before reaching the luminaire and driver. NEMA standards typically focus on certain product categories and performance measures including lumen output, color rendering index, and fixture life. These requirements are frequently well established and widely recognized within the industry, making it easier for manufacturers to design and test products that fulfill those standards. NEMA receptacles have 3-pin, 5-pin, or 7-pin contacts, supporting applications like voltage and dimming. High voltage wires may pose safety concerns, requiring additional safeguards. NEMA supports analog 1 to 10 volts and DALI protocols. However, analog dimming is unreliable, and DALI needs extra components. Compatibility with various LED drivers is also limited. NEMA's 7-pin connector provides auxiliary power, but many LED drivers and sensors don't support it. This can result in power instability and limited auxiliary voltage options. NEMA controllers convert AC to DC, but are prone to failure due to power surges. These components lead to shorter lifetimes compared to more durable Zhaga controllers. NEMA controllers often have more components than Zhaga controllers, resulting in greater space requirements. It is the current industry standard for street lighting applications, created and backed by the global Zhaga consortium. This standard originated in Europe and is now widely accepted as the de facto standard in most countries. The last remaining country, the United States, accepted this standard as part of their ANSIC 136.58 standard in 2019. In Zhaga architecture, the AC main supply connects directly to the luminaire, while the Zhaga receptacle links exclusively to the driver's low-voltage auxiliary power supply, enhancing overall functionality and safety. Zhaga standards promote customizable performance metrics, including mechanical dimensions and electrical properties. This flexibility fosters innovative LED lighting designs, but may complicate product comparisons and assessments across various manufacturers in the market. Zhaga sockets and controllers feature 4-pin contacts that handle voltage, dimming, and auxiliary power. These contacts operate without high-voltage wires, ensuring safer installation and operation, appealing to users and designers alike. Zhaga sockets and controllers inherently support DALI connectivity, which provides superior dimming accuracy and reliability. This eliminates the need for additional wiring or components, streamlining installation and enhancing compatibility with various systems. Zhaga sockets and controllers can automatically deliver supplementary power from the LED driver via pin 1. This functionality is widely compatible, ensuring efficient power management and stability across various lighting applications. Zhaga controllers boast extended lifespans and improved reliability. benefiting from a DC input that eliminates the need for AC/DC conversion. This simplicity reduces component count, enhancing overall system durability compared to traditional NEMA devices. Zhaga controllers are significantly more compact than traditional NEMA controllers, often being half or one-third their size. This reduction results from fewer components and the absence of AC/DC conversion, optimizing design space.